So welcome back, and today we're going to be looking at quadrilaterals. Those are four-sided shapes. So let's dive straight in. We're actually on page 92 of our workbook. All right, and the first interesting thing about a quadrilateral is that the angles always add up to 360 degrees, and that again builds on an earlier idea that we had. Previously, we've proved that the angles of a triangle add up to 180 degrees. Now, if we look over here, we've got two triangles in this quadrilateral. We've divided it into two triangles. This angle over here in the quadrilateral is actually made up of two different angles in a triangle, all right? But this plus this plus this plus this plus this and all of these angles added together will definitely come to 360 degrees, right? Because basically, and that will take in all the angles of this shape. Okay, so there we've got an angle. We've got a green angle, a red angle, a blue angle, and a purple angle. All right. Okay, but we know that this and this piece add to 180, and then these other halves or other bits of the blue angle and the red angle and the green angle all add up to 180 degrees. So our first big idea is that the angles always add up to 360 degrees. Now you might remember with triangles, any triangle, we can actually, if we've got lots of them, we can tile them. In other words, we can cover a whole area. The fancy word is tessellate. All right. If you cut out a four-sided shape and make lots of copies of it, so identical copies, then you'll be able to tessellate them. And we've given you the opportunity here to try and do that. And then to stick them onto this page. We're just going to show you how this actually looks. All right. All quadrilaterals tessellate. Okay, so let's just have a look. Okay, so here we've got shapes that pretty much look like squares, and we can see that they tessellate. All right, and that shouldn't surprise you, because if you've looked at the sort of the tiles on a bathroom wall, they tile with no gaps and no overlaps. All right, what's cool about this little diagram here, though, is that I can actually change the shape. All right, and if I sort of drag this, you'll see all these shapes are identical, okay, but they tessellate. They're covering a whole area, okay. So all quadrilaterals tessellate, all quadrilaterals tile, okay, which is cool. Right, next up we're going to look at classifying quadrilaterals. We're going to try and group them into different types, okay. But before we do that, we're just going to talk about the sort of the different types of quadrilaterals, and I'm just going to draw some of them here. All right. So the first thing is a kite. Now I think hopefully if you sort of have a picture of a child's kite, you've got some idea of what this looks like. Okay. Basically what it has is I've drawn that really, really badly. Let me see if I can do better than that. I'm sure I can do better than that. All right. So a kite would look something like this. Okay, and these two sides would be equal to one another, and these two sides would be equal to one another. So listen to it. Two pairs of adjacent sides equal. Adjacent means next to each other. So we've got a pair here. These two sides are next to each other and they're equal, and then these two sides are next to each other and they're equal. Right, that is a kite. Okay, the next one we're going to talk about is an arrowhead, and that makes fairly good sense. It just looks something like this. Okay. Okay, so that should be joined up, but it's basically just kind of one side's been sort of kicked in. It's kind of dented in. It's what we call a concave quadrilateral. Okay, and it's the only concave quadrilateral we deal with. The next one is a trapezium, and a trapezium has exactly, that shouldn't say at least, it has one set of parallel sides. Okay, no, in fact, at least one set is right. Sorry, at least one set. So here we go. All right, so this here is sorry. try and do that a bit better. This here is a trapezium. So we've got a line, we've got another line parallel, okay, and then we've got these other two sides that may or may not be parallel. Right, so that's a trapezium, okay? A parallelogram has two pairs of parallel sides, okay? So let's have a look at that. Parallelogram looks something like this. Okay, and what we have is we've got these sides parallel and then these sides parallel. Two pairs of parallel sides. Okay, right, the next one is a rhombus, okay? And a rhombus is a parallelogram, but it's actually a parallelogram with a pair of adjacent sides equal. And in fact, what a rhombus is, and we'll show you these again just now, a rhombus is like a square, all right, that's been tilted over. It is a parallelogram, it's got opposite sides parallel, all right, but it's got adjacent sides equal. So the sides, all the sides in fact are equal, but every side that's next to another side is equal. Okay, contrast that with a parallelogram, where parallelogram is almost like a rectangle that's been tilted over, okay? It's got opposite sides parallel, but it doesn't have sides next to one another equal. A rectangle is just a parallelogram with a 90-degree angle, and as soon as we put one 90-degree angle in, we get all the other angles to be 90 degrees as well, and we'll talk about why that's the case. All right, that's a rectangle. Okay, it's still a parallelogram, and we'll talk more about that. Okay, then finally a square is just either a rectangle where all four sides are equal, or it's a rhombus with a 90-degree angle in it. Okay, and then that's a square, and that we're familiar with that. Okay, this is still a rhombus, and in fact this is also a parallelogram, but we'll get more to that just now. Okay, what we want you to do now is we want you to try and classify those shapes number 1 to 12 on this page, and write down what they are. Okay, all right, just tick what they are. Okay, and we will give you some time to do that. Pause the video, have a go, and then we'll have a look just now and see how you went. Right, I do just want to go back before we start. I just want to correct something here. A trapezium does have just one set of parallel sides. Not at least one set. Okay, so shape number 1 is a parallelogram because it's got two pairs of parallel sides, but it is also a rectangle. Shape number 2 is a trapezium. Shape number 3, an arrowhead. Shape number 4 is a rhombus, and remember all rhombuses are parallelograms. Shape number 5 is a parallelogram. Shape number 6 is a rectangle, but remember that all rectangles are parallelograms. All right, so it's a parallelogram as well. Shape number 7 is a square. Now remember, a square is almost the ultimate four-sided shape. It is also a rectangle, it's also a rhombus, and it's also a parallelogram. Shape number 8 is an arrowhead. Shape number 9, I haven't got anything ticked for shape number 9. Let's have another look at shape number 9. Yeah, shape number 9 is nothing special, okay? Unless it's a kite, it's definitely not a kite. All right, so shape number 9 isn't any of them, which is why I haven't ticked any of them. Shape number 10 is a parallelogram. And shape number 11 and shape number 12 are kites. Let's just kind of have a look at them. There's 11 and there's 12. Those are both kites. They have two pairs of adjacent sides equal. Right, and so what we've got over here, and it's on its side, but you can obviously turn your book around, is the kind of classification. All right, now this is a set structure, okay? So for example, you'll see that rhombuses and rectangles are inside the set of parallelograms. So all rhombuses are parallelograms, but not all parallelograms are rhombuses. Okay, squares are right in the middle. Squares actually are rhombuses. They are also rectangles, and they're also parallelograms. Okay, they're just kind of slightly more special. They've got more properties. An arrowhead falls kind of right outside, and here's just a random quadrilateral which also falls outside. Okay, so in a way, a parallelogram is a special type of trapezium because it has a set of parallel sides. That's all it needs to have to be a trapezium, is a set of parallel sides. And a parallelogram does have that. So does a square. Okay, just to give you an idea of something similar here. If we think of animals, okay, then within that, the types of animals we get, one sort of family of animals are mammals. Okay. And then within mammals, we might get something like a zebra. So just listen to this. All zebras are mammals, and all zebras are animals. But not all mammals are zebras, and not all animals are zebras either. Okay, so a zebra is kind of a special sort of case, in the same way that a square in the middle is a special case. Right, now, this shape over here, let's just confirm that what we're dealing with here is a parallelogram. What we want you to do is we want you to look at that, and we want you to write down all the things that you can see, all right, apart from the fact that it's got parallel sides. That's part of its definition, okay? So we can mark those, and we've got parallel sides, okay? Both pairs of sides are parallel. Now, just pause the video and write down the other properties that you can see. See what else you can see, and all the things are marked on here. Okay, the first thing you might see is that the opposite angles are equal. The next thing is that the opposite sides are equal. The sides that are opposite one another are equal. The opposite sides are equal. And the last thing, which if you look very carefully, you look at the diagonals. The diagonal goes from one corner to the corner opposite it. If you look at the diagonals, they've got little lines on them. Now, interestingly, the diagonals are not equal in length. This one over here, I'm just going to draw it with a pen. This blue one, make this slightly thinner. This blue diagonal, all right, is actually quite a lot shorter than this yellow diagonal over here. But they cut one another in half. Okay, so opposite angles equal, opposite sides equal, and the diagonals bisect one another. What that means is they cut one another in half. This piece over here is the same size as that piece over there, and likewise this piece is the same size as this piece. Okay, diagonals bisect each other. Okay, and the word bisect means cut in half. Right, now the next shape, and again we want you to pause the video and we want you to write down all the properties of this shape. Okay, now this is still a parallelogram, okay, because it has opposite sides parallel, so it's a parallelogram. But the additional thing that it's got, all right, it's got a 90-degree angle. And notice we just say one 90-degree angle. But in fact, if one of the angles is 90 degrees, all of them become 90 degrees. And I'm just going to show you my parallelogram here again. Here's a parallelogram, okay, it can bend around like this. If one of the angles, I'm just going to make this bottom angle here 90 degrees. If that angle there is 90 degrees, you'll notice that all four of them go to 90 degrees. And there's a reason for that, because these lines are parallel, so these are co-interior, they're together inside. So if this one's 90, this one has to make up 180, so it also has to be 90. But these two vertical sides are parallel as well, so these two angles, this one and this one, are co-interior, so that one's 90, They add up to 180, this one's got to be 90. And these two are co-interior. Right, so as soon as you put a 90-degree angle into a parallelogram, you've got a rectangle. And all the angles are right angles. Okay, now because this is a parallelogram, it will have all the properties above. Okay, it's got one additional one. Write them all down, write down all its properties. So you're going to just copy the ones from above because it's a parallelogram, it's a special type of parallelogram. All rectangles are parallelograms, not all parallelograms are rectangles. Okay, pause the video and write them all down. Write down all the properties that you can see. Okay, so the first thing is the opposite sides are equal. The opposite angles are equal. Exactly the same as last time. The opposite angles are equal. Opposite angles equal. Right, the next thing is that the opposite sides are equal. All right, and because this is a parallelogram, we also know that the diagonals bisect one another. So they cut one another in half. But there's one additional thing. I want you to look very carefully at the diagonals. What do you notice about the length of the diagonals? They're actually equal. All right, so this piece and this piece are the same size, but they are also the same size as that piece. The total distance from A to C is equal to B to D. Now, if we look at a rectangle, we can actually see that. Okay, when we bend it over to become a parallelogram, that's not the case. The diagonals are not equal in length anymore. Okay, so the sort of additional property that we've got here now is that the diagonals are equal in length. Right. Okay, now let's look at this shape. This shape is a rhombus, okay? But it is a parallelogram as well. It's a special form of parallelogram. All rhombuses are parallelograms. Not all parallelograms are rhombuses. Okay, so we've got opposite sides parallel, which makes it a parallelogram. Because of that, all right, but what we're told now is that one pair of adjacent sides is equal. So in other words, we're saying what we're going to do is we're going to make that equal to that. But remember, for a parallelogram, the opposite sides are equal anyway. So in fact, a rhombus is really just like a square that's been tilted over. Okay, I always say it's like a square that's been hit by a car. Okay, all right, there it is. Okay, now let's write down, let's see what properties we can write down here, because there's a whole lot going on here. There's some additional things, all right? It's actually got 3 additional properties. Okay, let's see if we can see what they are. Right, pause the video, try and write them down. Okay, because it's a parallelogram, all the normal things for a parallelogram apply. The opposite sides are equal. The opposite angles are equal. This is true of any parallelogram. The diagonals bisect one another. True of any parallelogram. And then the 3 new ones. Okay, the first one is that the diagonals bisect one another. We know that already, but watch this. The diagonals are perpendicular to one another. So the diagonals are perpendicular. I'm going to use that little symbol. I'll also write the word perpendicular. That means at 90 degrees. Perpendicular. Right. The next thing is that the diagonals bisect the angles. In other words, those 2 bits are equal. Those 2 bits are equal. All right. And likewise, that little piece there and that little piece there and that little piece there and that little piece there are equal. So the diagonals bisect. Remember, bisect means cuts in half. The diagonals bisect the angles. Okay, and the last thing here is in fact that all four sides are equal. So actually, this is a little bit of sort of overlap, but because we've said the opposite sides are equal, in fact, all four sides are equal. Right, we could probably take this one out. Okay, right, now, here's an interesting idea, is that if you take any quadrilateral and you join the midpoints, you will always get a parallelogram. And we're going to finish off today's lesson just showing you that. Okay, so what I'm going to do here is I'm just going to draw a four-sided shape, any four-sided shape, right? From there to there to there to there. Okay, right, and I can move this around, I can drag a point around. Okay, what I'm able to do is I'm able to create a midpoint. So I'm going to put a point on the middle of there, the middle of this line, the middle of this line, and the middle of this line. Okay, now what I'm going to do is I'm going to draw a shape inside here, all right, joining up those midpoints. And lo and behold, that shape inside there will always be a parallelogram. Have a look at this. It doesn't matter where I drag this, I will always get a parallelogram. Okay, so if you take any four-sided shape and you join the midpoints of the sides, even an arrowhead, you will always get a parallelogram. Okay, all right, which is really quite cool. We're going to end today's lesson there, all right, and we will look forward to seeing you next time. Before we do see you next time, we would love you to try and just do the last one, all right? Let's just write this. If you join the midpoints of any quadrilateral, you always get a parallelogram. So that's how that works. Okay. Before we see you next time, we want you to see if you can fill in the properties of a square. Now, a square, remember, is a rectangle. It's a rhombus. It's a parallelogram. And its definition is a rhombus with a 90-degree angle, all right, or a rectangle with adjacent sides equal. Right. It's got 7 properties. Before we see you next time, we'd love you to try and write them all down. Have a great day, everyone. Salani Gahle.